Exponential and logarithmic equations. Now, here's where the fun begins and we actually get to start using some of these logarithms to answer some questions. Now, there are some guidelines that they provide for you. So if I want to solve an exponential equation using logarithmic forms, rewrite the equation with the term containing the exponent by itself on one side. Well, that's duh. This is what we do for linear equations. Okay. Divide both sides by the coefficient of the term. Well, again, nothing is new there. Change the new equation to logarithmic form. Solve for the variable. So the only real difference that we have to worry about here is switching it into the other form. So let's take a look at something like this. Now, if we were just to attack this as we normally would, what would you want to do to both sides of the equation first? You've got your 3,000 is equal to 150 times 10 to the 4t. Well, would dividing it by 150 make sense? Would that make sense for you to do? Okay. So if I do that, I'm left with what? What am I left with? 200. What? I want the t all by its lonesome. It's supposed to be what value, by the way? Thank you. Okay. See, the object of the game is to always get the variable on one side. Okay. So now I've got this simplified down to 10 to the 4t. Now, in order for me to go and solve this anything quicker, I mean, yeah, I could go and punch 20 into the graphing calculator, take 10 to the 4t, put it in there, and see where they intersect. But again, this is only going to be a ballpark answer. We want to be more exact, so we have to go through this process. So that means that I am going to have to rewrite this in terms of logarithms. So that means I got log base what? 10, because that's what that is, of 20 is equal to 4t. Does that work? So the last step that I want to do here is I want t all by itself. What would I have to do to both sides in order to get t by its lonesome? Divide by 4, right? So all I end up with here is going to be log base 10 of 20 divided by 4 is equal to t. Well, that's easy enough to put into the graphing calculator and come up with the answer. Get seconds. Reset. So I just put it in here and go log 20, since the calculator's in log base 10, right? Divide that by 4. And so t is going to be equal to 0.3253 is equal to t. There we go. Approximately, if you want to keep the little wavies in there. What? Well, what base is the calculator in? 10. Because you've been told that. Not too bad. So, let's see. What else do I got to play with here? Right? Double in time. Reading. Now, this little gem is probably the second most useful piece of information that we have for logarithms. First being the opportunity, or how we change it from exponential to logarithmic and logarithmic to exponential. This one takes care of one nagging little problem. How in the world do you use a calculator when you don't have a base that's 10 or you don't have a base that's e? Okay. What this says is that whatever I have, log base a of x means I can take log base whatever I want of x, log base whatever I want, as long as these are the same bases, a. So let's apply that here for a second. I want to be able to simplify this thing, evaluate log base 8 of 124. I cannot do that with my calculator because my calculator is only in base 10. So we apply the change of base theorem. That means that we are going to have log base 8 of 124 is equal to log of some base of 124 divided by the log of some base of 8. Now I got a question for you. What base should I use? 10. So if I've got this and I just think of it in terms of log base 10 all the time, now my calculator comes in handy again for this particular operation. So all I have to do is take log, and we're in base 10 of 124, close it, divide it by log of 8. Oops, sorry, too many of them. And log base 8, enter. I'm done. That's it. The change of base theorem is that darn handy. Okay? So make sure that you have that written down with your information. Let's see, what do we got? What do we got? Anything else of interest here? Okay. Again, it talks about, solving exponential equations using logarithmic properties. So let's go and work through a few of these. That is not what I wanted it to do. Okay, let's take care of the first one there. I've got 4096 is equal to 8 to the 2x. So if I want to go through and solve this, let's see. Should I rewrite this as log base 8 of 4096 is equal to 2x? Would that work? Now I got a sneaking suspicion about that number 4096. I don't know, it just bothers me. 8 times 8 is that, times 8 is that. Ooh. I seen that number there, and I recall as time goes on, you will get more familiar with these things that, it seems like 8 to some power would get me there. Okay. And there are a lot of times that those strange numbers come up like that. So you can always check that. So in this case, I could get by going log base 8 of 8 to the, what was that? That was 1 gave me 8 times 8 was 64, so that's squared, cubed, 4th power. Just double check, 8 to the 4th power. Yep. The 4 is equal to 2x. Now, from our basic properties, what do I get if I have log base 8 of 8? and I have a number up here. What is it always going to be? Look at your properties. Look at them properties. Those of you that aren't looking at your properties, look at your properties. What? Yeah, the exponent. Is that just what it's going to be? So log base 8 of 8 is going to be equal to, it's just going to be 4, isn't it? So that means 4 is equal to 2x. So that means 2 is equal to x. Okay. Now, what happens if we didn't see these wonderful things? Well, if I didn't see these wonderful things, I suppose what I would have done is set this up as log base 10 of 4096 divided by log base 10 of 8. It's equal to 2x, correct? So I probably would have just punched this in and gotten a number and then divided by 2, right? So if I go and take log of 4096, close it, divided by log of 8, close it, enter, divide 2, boom. Did I end up right back in the same place? Again, it's all what you see. What is it that sticks or jumps out to you when you're doing these problems? Is it possible that you wouldn't notice that? Probably. But are you going to catch it someplace else? Is it going to come out to be the same exact thing? And the answer is going to be yes. So let's try B here once. What would that happen with that? I want to solve this. What do you think the first thing I should do to attack this would be? What do you think, Sid? Divide by 6. Yes, most definitely. Simplify this thing down. So now I've just got 4 to the 3x minus 2 is equal to 20. Okay. Now, I got an unknown exponent. I got things simplified down as far as I could go. Does this look like logarithm to you? Okay. So this should be log base 4 of 20 is equal to 3x minus 2. Now I look at that 20 and I get 5. Nah, there's no powers going on there, so there's no simple thing that I'm going to work with right there. Yes, I could rewrite 20 as 5 times 4, so that means I get log base 4 of 5 minus log base 4 of 4, and we know 4 of 4 is 1. Don't try and make more work for yourself. Okay. So this is going to be some number, right? So I would end up dealing with this as change of base theorem, correct? Because I can't do anything else with it on a calculator or any of the rules that we've got. So I'm going to have log base 10 of 20 over log base 10 of 4 is going to be equal to 3x minus 2. Now I'm going to follow the same exact rules that I had before. Okay. This is going to give me some number, right? Now, a lot of times when you're writing this stuff out, why do you want to write out all of this stuff over and over again? Okay. I know what would happen here is whatever is in that box, I'm going to have to add 2 to both sides and divide by 3. So it's whatever is in that box plus 2 over 3. Is that going to be equal to x? These are the kind of shortcuts that you can take a look at, and as long as you're writing things out and understand what you're doing, simplify it for yourself. Don't think of this as some weird number. And do not, I repeat, do not round in the middle of calculations. Some of you have been doing that, and that's why some of you kind of lost some points on tests and quizzes and when we go through and do that. You get answers that are close but not quite. So be careful about that. So for this one here, clear things out, I'm going to take log of 20, close it, divide by log of 4. I got my number. Now it's an ugly looking number. Do not round this thing. Just leave it in the calculator because I've got it here and I can go plus 2 and then I can divide by 3. Boom. So I've got my answer of 1.387. So x is equal to 1.387. Leave it go at that. And there you go. Now you see how they were writing things out and what they did? Same thing. It's just how are you thinking about it? Are you writing it out? Do you have a logical path that can be followed? So let's see. Let's deal with this one here. So we got this. We're supposed to solve 6 plus 3 ln x is equal to 12. Well, I want to try and work through this now. Is it possible for me to drop this into the graphing calculator and just come up with the solution? Probably. But not really. I mean, that ln x, I got to do an operation to get to that. So if I've got 6 plus 3 ln of x is equal to 12. What do you think I should do first? How do I get that variable all by its lonesome? Subtract 6. So I subtract 6, 3 ln of x is equal to 6. Okay. Now what should I do? Yeah, divide by 3. So now I've got the ln of x is equal to 2. Okay. So now I'm in this form. I need to change it over into exponential form. I'm in logarithmic. Now I realize that when you're sitting here looking at this, getting that idea of the base and getting the look of it in your head doesn't always work very well. So could I rewrite this as log base e of x is equal to 2? Would that make sense to do? So now all I got to do is take e squared equal to x. So turn the calculator on here once. And I take second, e to the x, put in a 2, boom, done. 7.389. Okay. So I end up with x being equal to 7.389. Now, what happens if I wanted to do that graphically? No big deal. Same thing. I can put 6 plus 3 ln x, close it, go down here and say 12. Adjust my window. Okay. Well, we know that, are we going to be putting negatives in there? Well, no. So I'm going to put 0 in there. Let's see, this is going to be 0 as well. And let's see, as I look at this, well, my y max, I got to get 12, so I'm going to go up to 15. So I should see somewhere in there the answer. So it goes across. Second, track or trace, intersect, number 5. Boom, 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 boom. So did I again get a value that was exactly what I was looking for? The answer is yes. Do not look at this as super difficult. Everything that I have been doing is just based upon the algebra that you have had in the past. The only thing new here is working with the logarithm themselves. That's the new stuff, yes. But solving this has been the exact same rules that we had before. I told you 2 years ago that all you had to do was follow those very, very simple rules and you'll be okay. And they always keep repeating themselves. Let's try this one. See what this looks like. Okay. Now, this one's got a little trick to it. And it's not that I necessarily like using the trick, but I don't really look at it nicely. So, I've got ln of x plus 3, and I have ln of x plus 4. Okay, could I put that into a graphing calculator and have it go through and do it? Would that make sense? Now it says convert this to exponential form. Would that make, do you believe it makes sense to turn that into exponential form? What would that look like if I put it into exponential form? Well, I'm going to show you how they do it with exponential form here, but I don't always love, I don't like playing with it like that. Okay. Let's see. They didn't do that. Oh, well. They did it the algebraic way. Silly people. See what I would do. ln x plus 3 is equal to the ln of x plus 4. Note how the things take in, parentheses help here. This really means that we have the ln of x minus the ln of x plus 4 is equal to -3. Would you agree? So all I did is just brought 1 to the one side, brought 3 to the other side. Now, we've got logarithms and a subtraction sign. Do you remember our base properties? Well, would that be the ln of x over x plus 4? Yes? Is equal to -3. Is that good? Now remember, ln is the same as log base e of x, the x plus 4 is equal to -3. Now, flip it over into exponential form. So I've got 3e to the -3 is equal to x divided by x plus 4. Okay. Now my question for you is this a value? Is this some value? One of the things that we can do to help simplify equations like I did before is just do a substitution. You could say that that's equal to a variable, or I put a box around it. And now I want to think of it like this, is equal to x over x plus 4. Well, I want to get rid of this, so that means it would be times x plus 4 is equal to x, correct? If I keep going with this, that means I would have something x plus something times 4 is equal to x, right? Looking good so far? Looks ugly, doesn't it? So we can keep going with it, can't we? But see, this is what happens when you go and grab some weird number. So that number goes here, that number goes there. So that means that I would have to subtract, let's see, that means I would have the weird number x minus an x is going to be equal to what? It's going to be 4 times the weird number, right? Or if you like, this would be x multiplied by the weird number minus 1 is equal to 4 times the weird number. Yes, ma'am. I don't know what you're talking about. It's negative. When I factor out an x here and an x here. So if I do the distributive property, x times the weird number gives me the weird number x. X times the negative 1 gives me the negative x. Okay. So if I really want to do this one more step, x is going to be equal to negative 4 times the weird number divided by the weird number minus 1. Now, can I go and put that into a calculator and actually do the calculations? It said weird number. Who cares? It's a value. It's a number. We know how to work with numbers. So, calculator's on. Clear this off. So I am going to take negative 4, multiply it by, what was my weird number supposed to be? E to the negative 3. Close it. Enter. Go to, what did I do? Oh, negative. There we go. Enter. Okay, so I got my number. Okay, so that's my numerator. Now I have to divide that by the weird number again, which is, put the negative in there this time, minus 1. Close it. Enter. And there we go. 0.20958. All depends upon how you wish to look at things. Okay? So, they got down to that. Let's see, is there anything else? Nope. That would be it. So I'll let you guys get to work on this stuff.